Next example, evaluate integration 0 to 1, integration 0 to 1 dx dy divided by root 1 minus x square 1 minus y square. So uh, both the limits of x and y are what? Constants, and therefore the order is not matter in this example. That is, we integrate with respect to y first or integrate with respect to x first. So here the integration with respect to y first. So separate the integration, that is, write this bracket, and then integration with respect to y first now. And therefore 1 by root x square 1 minus x square becomes a constant quantity, and therefore it's come out the integration sign, because this 1 by root this 1 by root 1 minus x square 1 minus y square is separated as root 1 minus x square into root 1 minus y square, and then take this 1 by root 1 minus x square out of this limit, because this is now constant quantity, because the integration is with respect to y first, and therefore 1 by root 1 minus y square integration is sine inverse y from 0 to 1, and the value of sine inverse y is pi by 2, because sine pi by 2 is 1 and sine inverse 0 is 0. So value at the upper limit here is what? Sine inverse 1 minus sine inverse 0, and sine inverse 1 is pi by 2 minus sine 0 is sine inverse 0 is 0. Sine inverse sine inverse 1 is pi by 2. Therefore we have the value of upper limit 1 pi by 2, and that pi by 2 is constant, so it's come out of the limit, and therefore we have the integration 0 to 1 1 by root 1 minus x square dx, means integration with respect to x is sine inverse x from 0 to 1, and then again the value at the upper limit, that is sine inverse 1 minus sine inverse 0, and sine inverse 1 is pi by 2, sine inverse 0 is 0. So we have this pi by 2, and the value at 1 is pi by 2, therefore we have answer pi square by 4. Then next example, evaluate integration 0 to 1, 0 to 1, x square plus y square dx dy. Again, the limit, both the limits are constants, and therefore integrating first with respect to y or with respect to x. Here integration is with respect to y. X square is constant, its integration is x square into y, because integration of constant is what? Constant into variable. Y is variable, so x square is constant. So its integration is x square into y, and y square integration is y cube by 3 from 0 to 1. Then value at the upper limit, that is substitute y as 1 minus y at 0. So upper value at the upper limit minus value at the lower limit, and therefore we have this answer. And then its integration with respect to x is what? X cube by 3 integration of x square, and 1 by 3 integration is 1 by 3 is constant, 1 by 3 into variable. Variable is now x from 0 to 1, and then value at the upper limit, that is substitute x as 1, so 1 by 3 minus substitute x at 0, we have 0. So value at the upper limit minus value at the lower limit, we have the answer 2 by 3. Next problem, integration 0 to 1, integration y to y square plus 1, and this the limit, this limit is in terms of y, so this is on x, and now this is on y. So this is on the x, limit is on x, y to y square plus 1, and this is the limit on y, because this limit y square plus 1 y is in terms of y, and now the order is what? The limit of x is in terms of variable, so integrate with respect to x first. We cannot integrate this example with respect to y first, because the limit of x is in terms of variable. So by using Febini's theorem, we integrate with respect to x first, because the limit of x is in terms of variable, and then integrate with respect to y. So integration is separated here, this bracket, and now this becomes a single integration. This becomes a single integration. So every problem of double integration, triple integration, after first step it converted to single integration. Just uh, fix the order of the integration. That is, if the limits are in terms of constants, then you can integrate it with respect to x first, or with respect to y first, or with respect to z first. That is, we can change the order easily, or we can integrate with respect to x, y, or z first. But if the limits are not constant, then what is the order of integration? Suppose the limit of x are in two variables. Suppose there are three triple integration, and suppose the of x is the limit of x is in two variables, then integrate first with respect to x. Suppose the limit of z is in terms of one variable, then secondly integrate with respect to z, and then integrate with respect to y. Okay, so this is the order. Uh, so, and in order to change the order of integration, we have to draw the figure from the limit and then take a strip parallel to either x-axis or y-axis. So that is already covered in the previous example, change of order. Also, there is separate chapter, separate topic for us, that change the order of integration. We will see in next lecture that the change of order. So here is no need to change the order. When we change the order, if the question in the question, the instruction is that change the order and then solve, then we change the order. Or in some examples, if integration becomes complicated, then there is a need to change the order of integration. In that case, we change the order of integration. Otherwise, don't change the order of integration. But what is the sequence of order? Here the limit of x is in terms of variable. So integration with respect to x first is must in this example. So in this example, the both limits on x and y are constants. And so integrate with respect to y first or integrate with respect to x first. We get the same answer. But if the limit are in variable, then the preference is what? The limit of in terms of variable. So here the limit of x is in terms of variable. So we need to integrate this example, it is integration with respect to x first. If the limit of y is in terms of variable, then we integrate with respect to y first. So here is the integration with respect to x first, and then integration here integration is with respect to x. Dx means integration is with respect to x. And so y is constant, and then integration of x square is x cubed by 3, upper limit, lower limit, then value at the upper limit. That is substitute x as y square plus 1. This is the value at the upper limit. And the value of this bracket at y, that is substitute x as y, we get this is the value at the lower limit. So value at the upper limit. So square bracket, what is the arrangement of bracket? Right, square in square bracket, and upper limit in the round bracket minus lower limit in the round bracket. So this is the arrangement. Or write the curly bracket and then write upper limit in square bracket minus lower limit in square bracket. So this is the arrangement of the brackets. So value at the upper limit minus value at the lower limit into dy. And then simplification of this square bracket is this. Take this 1 by 3 as common. And then integrating with respect to y. 1 by 3 is constant, and the y raised to 7, integration is y raised to 8 by 8. Similarly, y raised to 5, integration is y raised to 6 by 6. Similarly, y cube, y and y raised to 4 integration. And lower limit is 0, upper limit is 1. Then value at the upper limit, that is 1 by 3 is common factor. The value of this bracket at y is equal to 1 is this. And minus value at this bracket at x is equal, y is equal to 0 is 0. So we get the answer 67 by 120. Okay. Next is evaluate double integration x into y in bracket x plus y dx dy over the area between y is equal to x square and y is equal to x. So we need to draw this figure to solve this problem. That y is equal to x is the straight line passing through origin and which divides the plane first and third plane in two equal parts. That is making an angle 45 with x-axis as well as 45 with y-axis. Y is equal to x line. So on this line, y and x coordinate are same. Every coordinate of every point, x and y coordinate are same. So, and y is equal to x square means is the equation of parabola, and x square means around y-axis. X square means around y-axis, and y is equal to plus x square means is above the x-axis. Around y-axis, y is around y-axis because there is square of x, If there is a square of y, then it is around x-axis. If there is a square of y in the equation of parabola, then it is around x-axis. But here the square of x means it is around the y-axis and is above y-axis, because above x-axis, because y is plus x square. If y is minus x square, then it is below the x-axis. Okay, so this is the figure of y is equal to x square. This parabola represents y is equal to x square, and this is the area bounded by these two curves. And we have to integrate this integration with this on this area, over this area. So write double integration over r, write this region as r, denote r, and x y x plus y dx dy is equal to, now uh, we have to integrate, suppose first with respect to y, we can integrate this equation, this integration with respect to y first, and as well as with respect to x first. Okay, so suppose we decide that the integrating this equation, this integration with respect to y first, then take strip parallel to y axis. So right here strip, draw here strip parallel to y axis, like this, like this, and then this strip parallel to y axis, then its one end touches to the x square, y is equal to x square. So and the other end of the strip touches to the equation or the straight line y is equal to x. So from this to find the values of y, so obviously y is x square is lower limit, y is equal to x is upper limit. Okay, if we have to integrate, suppose with respect to x first, suppose we have to integrate with respect to x first, then take strip parallel to x axis, like this, like this, take strip parallel to x axis, and then its one end touches to the line y is equal to x, and another end touches to the line to the curve y is equal to x square. So from these two equations, find the values of x. So x is y, now y is the lower limit now, and y is equal to x square means x is root y, so root y is the upper limit. If I have to integrate first with respect to x, then what are the limit? Lower limit is y and upper limit is root y. Okay, and next is integration with respect to x. What are the, here the, suppose the integration is with respect to y first, then with respect to x. So what are the limit of x? So in order to cover, here the strip parallel to y axis, because integration is with respect to y first, so strip is like this, parallel to y axis, not this, they like this, y axis parallel to y axis. Okay, so in order to cover this area, we have to move this strip from this point to, right, perpendicular from this point to this point, this on x axis. So we have to move the strip from this point to this point in order to cover this area. And so this point, if we draw the perpendicular on this x axis, what are the coordinate of this point? So coordinate of this point are obtained by solving these two equations. That is, substitute y is equal to x in this equation. We have x is equal to x square, means x square minus x is equal to 0. Take x as common. So we have x into x minus 1 is equal to 0, means x is 0 or x is 1. If x is 0, then y is 0. X is 1, then y is 1. Okay. So what are the coordinates? 0, 0. Point of intersection of these two curves, parabola and straight line, intersect at in the 2 points 0, 0, and this point is 1, 1. So if we draw the perpendicular from this point on this x-axis, then it meets at a distance 1 from the origin. That this is the 1 point, 1. And if we move the strip from this point to this point, that is this point, then this area is covered. And so x runs from 0 to 1. Okay. So if you take the strip parallel to x-axis, if we have to integrate, suppose first with respect to x, then what are the lower limit and upper limit of the y? Y is x. What are the limit? X, y, and root y. Okay. And what are the limit? What is the limit of y? So strip is parallel to x-axis now. X-axis. Strip is parallel to x-axis like this. And in order to cover this area, we have to move the strip from this point to this point. What is that point? That is perpendicular from this point to y-axis, and this. So this point is now cuts the y-axis in the point 0, 1. that is y runs from 0 to 1. Okay, y runs from 0 to 1. So if the same question is that this is given, suppose this is given, and the question is change the order. So what is its answer? Is equal to integration, double integration, y runs from x runs from 0 to 1, y runs from x is equal to x runs y runs from double integration, and y runs from 0 to 1, like this. X runs from 0 to 1, so y runs from 0 to 1, and x runs from y to root y. Okay, then this write x into y, x plus y, dx dy. Okay, so I will share this example with you by changing the order. So here is the integration is with respect to y first. Now integration is very simple. Now simplify this bracket. I will multiply by this in bracket and then integrating with respect to y first. So x square into y, x square, y square by 2 integration, and x into y square, x into y cube by 3, its integration. Lower limit x square, upper limit x. Then value at the value of this bracket at upper limit, that is substitute y is equal to x, we have this value, minus value of this bracket at lower limit, that is substitute y is equal to x square. This is the value at the lower limit. So what is the arrangement of the bracket? Square bracket, right? In round bracket, value at the upper limit, minus in round bracket, value at the lower limit, and its simplification is this. And then its integration with respect to x is what? X raised to 4 integration x raised to 5 by 5 get cancelled. In this way, integration of x raised to 6, x raised to 7 is this. 0 to 1, then value at the upper limit, that is substitute x as 1, we have this value, and substitute x as 0, we have the 0 value. So we have 3 by 56 is the answer. Next is evaluate double integration root 1 minus x square minus y square dx dy, where d is the region bounded by the curves or lines. X is equal to 0, y is equal to 0. X is equal to 0 means y axis, y is equal to 0 means x axis, and x square plus y square is equal to 1 is the equation of circle with center 0 0 and radius 1 in the first quadrant. So the shaded region is this, that is obviously x is equal to 0, y is equal to 0, and this circle, so in the first quadrant. So this is the region D. Okay, and we have to integrate this with over this region D, Okay, so double integration over D, or root 1 minus x square minus y square dx dy is equal to integration. Now suppose we have to integrate here with respect to x first, then take strip parallel to x axis, right? Like draw this figure, strip at this place, like that is parallel to x axis. Draw the strip parallel to x axis, and then what are the limit of x? So it's one end of the strip touches to the line x is equal to 0, we have x is equal to 0 as the limit, and the other line touches to the other end of the strip touches to the curve or circle x square plus y square is equal to 1. So after solving this equation, simplifying this equation, find the value of x. What is the value of x? So x square is 1 minus value of y. So y square is what? 1 minus x square, and therefore y is root 1 minus y square. Root 1 minus y square. Root 1 minus x square, y, value of y. So in order to integrate with respect to here is the integration, here write first dy and then dx, that is integration is with respect to y first. So in order to integrate with respect to y first, take strip parallel to y axis. Suppose this is the strip, take strip parallel to y axis, and then its one end touches to y is equal to 0, and other end touches to this circle of this strip. Then for y, value of y is what? Root 1 minus x square is the upper limit. And in order to cover this area, we have to move this strip parallel to x axis from 0 to 1. That is, and therefore the limit of x are 0 to 1. This is the limit of y. So this is the integration with respect to y first, and then with respect to x. Same problem we can solve by integrating with respect to y first. So I will share you the answer uh, of the same problem by integrating with respect to x first. Now integration is with respect to y, means 1 minus x square is constant quantity, and therefore suppose 1 minus x square as a, 1 minus x square as a, 1 minus x square as a square, and so 1 minus x square as a square, root a square is what, a, and 0 to a, 0 to a, root 1 root a square minus y square dy dx, and then its integration is what, by using the uh, rule of integration we have, it is y by 2 root a square minus y square plus a square by 2 sin inverse y by a. Use the rule integration, root a square minus x square is what, y here is, y is variable, so y by 2 root a square minus y square plus a square by 2 sin inverse y by a from 0 to a. Then find the value at the upper limit, that is substitute y as a. So this quantity becomes 0, and this quantity is sin inverse y by y, that is sin inverse 1, a square by 2 sin inverse 1. This is the value at upper limit, that is by substituting y as a, and then substitute y as 0. So we have, this is value is 0, and sin inverse 0 is 0, therefore this is also 0. So value at the lower limit is 0, and value at the lower upper limit is this. Sin inverse 1 is pi by 2, and then resubstitute this a square as 1 minus x square, 1 minus x square, a square as a 1 minus x square, substitute a square as 1 minus x square. So it is just for simplification, it is not integration by substitution, it is for just for substitution, just for simplification, that is 1 minus x square is constant quantity with respect to y, integration is that, therefore, and then take pi by 4 as a common factor, we have a square as 1 minus x square, and its integration with respect to x is x minus x cube by 3 from 0 to 1, lower limit upper limit, and the value at the upper limit is 2 by 3, 1 minus 1 by 3, that is 2 by 3, and value at the lower limit is 0. So we have the answer pi by 6. So we will see the similar problems, remaining problems in the next lecture.